All right, so unfortunately, with everything that we need to learn, the analogy lesson, which is super short, we did not get a chance to go over. I generally like doing the analogy lesson before we actually do the quiz that you guys did today on Friday. Whatever day you're watching this, we did on Friday. And what this lesson will do is it'll give you a different way of thinking about the content. And I will ask you on the test, because it's such an excellent way for me to determine your understanding of a concept, a question in the form of an analogy. All right. So in addition to the actual lesson, I've also provided you with a 3 quizzes, which is kind of like Kahoot, and you can work through them at your own speed to see whether or not you understand the concept. So analogies are a really good way to explain a concept in biology, chemistry, physics, because what you're doing is you're taking an abstract concept like how big this solar system is or how small an atom is, something that's pretty abstract that you can't actually visualize it, and you are putting it to something that's concrete. So this is kind of like an English lesson, but that's perfectly okay because we do need to communicate with each other. So by definition, an analogy has 2 parts. It has an analog and a target. So my target is a cell. I want to explain how a cell works. We learned about that in grade 10. And so this cell, if you don't understand the fundamental pieces and understanding related to the cell, then I can use the city as my analog to explain it. So we assume that you understand things about roads, and then I can really equate that to a cytoskeleton. You understand about powerhouses, so I can equate that to a mitochondria. You understand things about the city hall, so I can equate that to the nucleus, and so on. So if you understand the analog, then you can understand the target. That's the goal here in these analogies. So analogies are very, very effective in the science world. Okay. So this PowerPoint's up and available. You can take a look at it at your own speed. Remember I talked about in the last lesson how important it is to know the parts of words. It allows you to determine unknown words, what they mean. I specifically talked about iso and hyper and hypo and tonicity and osmolarity. So here we have ana, which means up, back, or again. And we have logos, which is reason. You have logy, which is study of. So biology, zoology, psychology. So analogous. Now, analogies come in a variety of different forms. So one of the forms that you may have learned in English class is the classic metaphor, where you have an understanding of something like a shrew versus an elephant. You look at them and you count how many heartbeats they have. And if you look at a little tiny shrew, its heart's going super, super fast, maybe 2 times a second. And an elephant, its heartbeat's going maybe once every 2 seconds, if not slower. So if I were to ask you to explain the metabolism of these animals, if you understood anything about car engines, little tiny engines versus big engines, and how they turn over and drive the vehicle from point A to point B, you could use your understanding of an engine to explain the metabolism of an elephant versus a shrew, for example. That's how metaphors work. Another analogy here is when I take the atomic model we learned about in grade 9, the Bohr-Rutherford model, and if you don't understand it, I can equate it to the solar system, which you learned in elementary school. And the solar system here has the sun, which equates to a nucleus. It's most of the mass of the solar system. The nucleus is most of the mass of a atom, and electrons are very little, and they circle around the central nucleus, whereas in the planets are relatively small compared to the sun, and they revolve around the sun. Now, what's important to understand is that these are only analogies. They are not perfect. As a matter, they can't be. There's always going to be some kind of difference. So science can use metaphors. You'll see it in a lot of books. But what I'm going to suggest to use when you're first doing this is use a simile. They're very easy. So you say a cell is like a city, right? So if we're using the word like or as, we have a simile. Now, I'm going to give you a bunch of different similes here. And I'm going to do this in a test situation. Because I hadn't taught it before, I didn't put any on the quiz, otherwise I would have. Now, let me just back up. When you're doing a proper analogy, you'll see on here, my first page, that on your analogy that you do on your Submitted presentation, because I know you guys have already done your Flipgrid, so don't revise it. You're not going to get marked up or down. But a proper analogy will have points that indicate why it's similar to the target, the analog and the target, and how it's different. So you need to have both those points. So when you submit your final presentation on Monday, make sure that you update your analogy to reflect a full analogy. You'll notice that I'm marking it based on this level 1 to 4. So I'm looking for similarities, and I'm specifically looking for why is the analog and target different. Okay, so now let's jump into how I'd use this to assess you. So a heart is like a pump. So we'd be in class right now, and we'd be doing thumbs up and thumbs down, and I'd ask you, do you agree? And if you think about what a heart does, how it moves blood throughout your body by squeezing, relaxing, and what a pump does, it moves water or fluid through a tube and a big reservoir, like a pool, then you would absolutely accept this as a acceptable simile or analogy to describe the scientific concept. A heart is like a stone. So I'd ask you to consider this. Think about what a stone does. It's probably the antithesis for life. It's inanimate. It doesn't move. It's static. It just sits there. And a heart is like the epitome of life. So this one here we would absolutely reject. I would not accept an acceptance on this question. Sometimes with these questions, I'll accept either an acceptance or rejection, depending on how well you justify it. All right. So these questions, typically you won't get 1 mark for accepting and then 1 mark for the answer of why, the justification. You'll only get 2 marks for how you explain the concept. So lipid is like coal. So do you know what coal does? Coal is an energy source, right? Over millions of years, it's been put under pressure, carbon, and we pull it out of the ground and we use it to produce energy. So long-term energy. So lipid is also a long-term energy inside our body. So I would absolutely accept this. Lipid is like a piece of a puzzle. So think about what puzzles are, how they're made up of all these different pieces. And depending on how you want to explain it, I might say an amino acid is like a piece of a puzzle. That makes sense to me. But a full lipid, a triglyceride, as a piece of a puzzle, I don't think so. I would reject that. So this allows me to determine your understanding of a concept by how well you're able to accept or reject an analogy. So throughout this PowerPoint, you're going to see a bunch of lipid similes, carbohydrate similes, and protein similes. I'm going to open them up here. So I'm going to put those probably in the Google Classroom, I think these links, and then you could practice on those, or you can go through the PowerPoint and you'll see them there as well. All right, so that's my analogy lesson. It was less than 10 minutes long, so you're good to go. Remember, you do not need to revise the Flipgrid. That's done, it's up. I'm not going to assess how good your analogy is on the Flipgrid. I will assess your analogy in the final PowerPoint, Google slide, whatever, submission on Monday. All right, have a fantastic weekend and goodbye.